In this episode, we're going to focus on a privacy engineering idea that sounds simple but becomes challenging the moment data starts moving: consent tagging. New learners often think consent is a one-time click, like checking a box, but in a real system, consent is more like a living condition attached to data that determines what the organization may do with it over time. The hard part is that data rarely stays in one place, because it flows through applications, databases, analytics, logs, vendors, and sometimes AI pipelines, and each hop is an opportunity for the original permission to be forgotten. Consent tagging is the practice of attaching the right labels to data so that downstream systems can enforce the same limits that existed at collection, even when the data is aggregated, transformed, or transferred. When this is done well, the organization can prove that it respects user choices consistently across the lifecycle. When it is done poorly, consent becomes a front-end promise that silently breaks in the back end, which is one of the fastest ways to lose trust. A solid foundation begins by understanding what consent means in a privacy program, because consent is often confused with notice, preference, or a general relationship with a service. Consent is an explicit permission given by a person for a specific use of their personal information, and it often has scope, meaning it is tied to a purpose, a set of data categories, and sometimes a set of recipients. Consent can also have conditions, like being revocable, time-bound, or dependent on the context in which the data is used. Beginners sometimes assume consent is always required, but many privacy programs rely on different legal bases depending on the use, and consent is one of them, not the only one. Even so, when consent is used, it must be honored precisely, because it is a promise made directly to the person. Another beginner misunderstanding is thinking that consent is captured only once, but real systems often need to record when consent was given, what text was presented, what version of a policy applied, and what choices were made. This history matters because it supports accountability, and it matters because consent can change over time. When you define consent as a structured, enforceable condition rather than a vague checkbox, consent tagging becomes easier to reason about. Consent tagging starts with a key question: what exactly needs to be tagged? The data subject, the data item, the data use, or the process? In practice, tagging often touches all of these, because consent is about people, but it must be applied to the data that represents them. A consent tag can be thought of as metadata that accompanies a record or a dataset, describing what uses are allowed, what uses are disallowed, and what constraints apply. Beginners should recognize that there is a difference between tagging at the person level, like a global marketing preference, and tagging at the data element level, like a specific location history that was collected under a particular permission. If you only tag at the person level, you may miss cases where one category of data was collected under different terms than another. If you only tag at the data element level, enforcement can become complicated when data is aggregated and transformed. A mature design often uses a combined approach, where consent state exists in a central consent record and is also propagated as tags to the data flows that need it. The important concept is that tags must be meaningful to enforcement, not just decorative labels stored somewhere. When tags are structured to drive decisions, they become operational. To make consent tags travel with data, you must first make them stable and unambiguous, because tags that are inconsistent across systems will be ignored or misinterpreted. A stable tag uses consistent names, consistent values, and consistent meaning, so that different teams and systems treat the same tag the same way. This often requires defining a consent taxonomy, which is a structured way to represent the categories of consent the organization supports, such as marketing, personalization, analytics, or third-party sharing. Beginners sometimes assume taxonomies are bureaucratic, but without a shared vocabulary, one system will interpret a tag as allow while another interprets it differently, and the result is silent failure. Tags should also encode the scope, such as which purposes are covered and which data categories are included, because consent is rarely blanket permission. Another design element is versioning, meaning the system should record which consent definition or policy version was in effect when the consent was captured, because the meaning of consent can change if the product and disclosures change. When tags are stable, scoped, and version-aware, they can be carried across system boundaries without losing meaning. This is how consent becomes durable rather than fragile. A common failure mode is that consent is stored in one place, like a user profile table, while data flows through other systems that never check that table. For example, an analytics pipeline might process events and store them in a warehouse without consulting the user's consent state at the time the events were generated. Another failure mode is timing, where consent changes but downstream systems keep using older copies of data because they are not updated quickly enough. Beginners should understand that consent is a time-dependent condition, so your design must handle both the consent state at collection and the consent state at use. In some cases, you must enforce consent based on what was allowed when the data was collected, and in other cases you must enforce based on the current preference, especially when consent is revocable. This introduces the need for systems to reference consent reliably and for tags to reflect the right time context. A privacy-aware approach avoids relying on ad hoc lookups during processing because those lookups can fail, be slow, or be bypassed. Instead, systems can propagate consent tags along with events or records so that downstream consumers see the tags as part of the data package they receive. When consent information is present where decisions are made, enforcement becomes practical. Propagation across system boundaries often requires designing data contracts that include consent metadata because interfaces determine what travels. If an API returns a dataset without consent tags, the receiving system has no way to enforce the original limits unless it performs its own lookups and interpretation. If a message event is published without consent context, subscribers may ingest and store the data before they ever consider whether they should. Beginners should connect this to the earlier idea that contracts and interfaces are privacy boundaries because they define what downstream systems can know and do. A privacy-aware design includes consent tags in the payloads or in associated metadata fields in a standardized way, and it requires that consumers treat those tags as mandatory inputs to decision-making. This can be supported through validation, where services reject data that lacks required consent metadata, preventing silent ingestion of untagged data. Another approach is to ensure that when data is transformed, the transformation includes rules for how consent tags should be preserved, combined, or narrowed, because transformations can unintentionally strip metadata. When consent tagging is part of the contract, it is less likely to disappear during integration. Enforcement is where tagging proves its value, because tags must drive behavior rather than merely describe it. Enforcement can happen in multiple places, such as at ingestion, at query time, at export time, and at processing time for analytics or personalization. A simple example is preventing a dataset labeled as no marketing from being included in marketing campaign audiences. Another example is preventing personalization models from using data collected under a consent choice that excluded such use. Beginners should understand that enforcement needs to be consistent and preferably centralized, because if each team implements consent logic differently, errors and drift are inevitable. Policy enforcement can be supported through shared services or shared libraries that interpret consent tags the same way everywhere, reducing the chance of inconsistent handling. Another enforcement practice is to ensure that high-risk actions like exports and third-party transfers include consent checks and are logged for accountability. When enforcement is built into systems, user choices remain meaningful even when the organization operates at scale. Without enforcement, consent tagging becomes performative, and performative consent is both unethical and risky. A major challenge is dealing with derived data, because analytics and aggregation can produce outputs that seem disconnected from individual consent. Beginners might assume that once data is aggregated, consent no longer matters, but that is not always true, especially when aggregates are small, linkable, or used for individualized decisions. If an analytics process uses personal information to create a profile score that influences offers or content, that output may still be subject to the original consent constraints. Consent tagging, therefore, needs a strategy for how tags propagate into derived datasets and models, and that strategy should be conservative when the derived output can still impact an individual. Another tricky area is that a single derived dataset may be built from sources with different consent states, meaning some records are allowed for a purpose and others are not. In that case, the dataset cannot be treated as uniformly permitted, and enforcement must be capable of filtering records based on tags. Beginners should see that this is not just a technical problem. It is a design problem that affects how analytics pipelines are built and how datasets are partitioned. A privacy-aware approach often separates data into consent-compatible partitions so that downstream use does not require complex filtering in every query. When derived data respects consent boundaries, the organization avoids silently violating user choices through the back door of analytics. Revocation is one of the most important aspects of consent tagging because many consent choices can change, and a privacy program must honor those changes in a timely and consistent way. If a person withdraws consent for a certain purpose, the organization must stop using their data for that purpose going forward, and depending on the context, may need to remove their data from certain datasets and models. Beginners should understand that revocation is hard precisely because data has already spread, which is why consent tagging must be designed to support propagation of changes. That can include signaling mechanisms that notify downstream systems when consent changes, and it can include processes for retroactive cleanup or exclusion when required. Another part of revocation is decision traceability, where the organization can show that after a certain timestamp, data was no longer used for disallowed purposes. This traceability requires logging of consent changes and logging of consent-based enforcement decisions, which helps defend the program during audits and investigations. Revocation also requires avoiding designs that make consent irreversible, such as building models that cannot be updated or creating datasets that cannot be filtered. When revocation is planned for, consent remains real rather than symbolic. Consent tagging must also survive system boundaries where data leaves the organization, which is where tagging becomes both a governance and an engineering issue. If you transfer data to a vendor or partner, the consent constraints should travel with the data, either through contractual requirements, technical tagging, or both. Beginners should understand that a tag inside your database does not automatically control what happens in a vendor system, so you must ensure the vendor understands and enforces the same constraints. This is why data sharing arrangements should specify permitted uses, prohibited uses, retention periods, and deletion obligations, and why technical measures should minimize what is shared in the first place. Another important point is that third-party systems may not support your exact tagging format. So you may need to translate tags into a form the recipient can enforce, or you may need to restrict transfers to only data that is permitted for the specific purpose. Accountability is crucial here because if a vendor violates consent constraints, the harm still affects the people and often the organization that collected the data. When consent tags and obligations cross organizational boundaries, privacy intent stays attached to data even when direct control is reduced. A frequent beginner misconception is that consent tagging is just a user preference system, like a settings screen, but consent tagging is much broader because it is an infrastructure for enforcement across the full data lifecycle. Another misconception is believing that once a consent value is stored, everything downstream will automatically honor it. But without propagation and enforcement, downstream systems will not even know it exists. There is also the misconception that consent is binary, like yes or no, when in reality consent can be purpose-specific and context-specific, requiring more nuanced representation. Beginners should also be cautious about believing that tagging alone creates compliance, because tagging is only as effective as the systems that enforce it and the processes that keep it current. This is why ownership and asset management matter, because someone must be accountable for consent definitions, tag taxonomy, and enforcement consistency. Another important point is that consent tagging should not become an excuse to collect more data because you think tags will control it, since minimization remains essential. Consent is permission, not a requirement to collect, and permission does not eliminate risk. When these misconceptions are cleared away, consent tagging becomes a powerful tool that supports trust through reliable, system-wide behavior. To operationalize consent tagging, organizations need clear ownership, consistent standards, and routine verification that tags are present and being honored. Verification can include testing data flows to ensure tags are not dropped during transformations, auditing downstream systems to confirm consent filters are applied, and monitoring for unexpected uses that suggest enforcement gaps. Beginners should understand that verification is essential because consent failure modes are often silent. where systems keep working and data keeps flowing even when constraints are missing. Another operational aspect is documentation of consent definitions and mapping between consent options and permitted uses, so teams build new features with the right assumptions. This is where embedding privacy into the SDLC supports consent tagging, because teams can include consent impact checks during design and review. It also helps to have a clear process for introducing new consent categories, because expanding consent options without strong governance can create inconsistent tagging and enforcement. When operational practices are strong, consent tagging becomes reliable across time, teams, and technologies. When operational practices are weak, consent tagging becomes a patchwork that users cannot trust. As we conclude, the main lesson is that consent tagging is how you make user choices durable as data moves, transforms, and spreads across systems, services, and partners. Consent is not just a front-end checkbox, but a condition that must be represented in a stable taxonomy, attached to data through consistent metadata, and enforced wherever decisions about use, sharing, and retention are made. Silent privacy failures happen when tags are missing, inconsistent, stripped during transformation, or ignored by downstream consumers, which is why propagation and enforcement must be designed into interfaces and data contracts. Derived datasets and analytics must handle mixed consent states honestly, and revocation must be planned for so changes can propagate and prevent continued disallowed use. When data crosses organizational boundaries, consent constraints must travel through both technical tagging and governance obligations, because control does not end at your system boundary. Finally, operational verification and ownership keep the tagging system aligned with reality, so consent remains meaningful over time. When you can explain consent tagging as a lifecycle control that survives system boundaries, you are thinking like a privacy engineer who protects trust through predictable, enforceable design rather than through hope.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit DailyCyber.News.